All right, back to homework during my lunch break. Because it's important. All right, so 11 is about a student's attention span. It says it decreases roughly 15% for every 6 minutes in class. And what we have to do is we have to assume I have 100% to start, which I know I don't. But anyways, write a model describing a student's attention span. So 100% is the number 1 as a decimal. So the amount after time passes is that initial principal of 1 times 1 minus 0.15 to the t over 6, because it's every 6 minutes. Cleaning that up, the 1's understood, 0.85 to the t over 6. All right, when will a student's attention span be 70% of what they started with? And it's not 12 minutes. It doesn't work that way. Some kids think it does. They think they're geniuses and they can manipulate two numbers. But 0.7 would have to equal 0.85 t over 6. And you could use TI-84 to do that. There's your y1, there's your y2. And we'll just plug some crap in. 0.7, 0.85, rooftop, sorry, forgot the x. No, didn't. My brain's on a different course. Now you can see what I typed. Zoom 6. And there's an intersection here somewhere. Second trace 5. Oh, nope. You hadn't seen it yet. Let's see here. I'm going to make this look a little better. I'm going to change the y max to be 1. Oops, and I need to change the y min too. The y min to be 0. There is your attention. There is 100%, or sorry, there's 70%. Now you can start seeing the curvature. Look out to about 20 minutes, because I probably lost 30% of their attention span 20 minutes in. There she is. Second trace 5. Get close and press enter 3 times. Enter, enter, enter. Looks like it takes about 13.2 minutes. What percentage of a student's attention do I have after 48 minutes? Because that's our typical thing. Well, the amount in 48 minutes is just going to be when I plug in a 48 right there. And if you don't know what 48 over 6 is, it's 8, but whatever. If you don't know that, then so be it. Not a big deal. It is a big deal, but you can still push buttons, right? Looks like I got about 27.2% of their attention span. Seems reasonable. I got a hunch it's quite a bit less than that. This is supposed to be for the next one. It's not that hard. Draw a right triangle. So you're told in number 12, the sine of theta is 4/5, and theta is an angle that exists in quadrant 2. So what you do is you draw in quadrant 2 a right triangle, such a manner that the right angle is formed with the x-axis. That's how you draw. You don't draw it any other way. So from your geometry courses, you were taught that sine was opposite over hypotenuse. You do a line up with 4/5. So we're going to put what's called theta prime here. There's your angle. It's called a prime angle. So opposite's 4, hypotenuse is 5. Everybody knows about 3, 4, 5. Now when you start drawing in quadrants, signs matter. That is moving left. Big deal. So the tangent of theta is opposite over adjacent, always has been, always will be. It's 4 over -3 or -4/3. And here's all the ACTs. 47 looks like a geometry problem. It says G to H is 10 inches. That means this is 5, this is 5. Because they tell you that R and such are midpoints. What is the area of parallelogram QRST, which is presumably a square, one would think. So what I notice about these little right triangles is 5, 5. I've asked you to memorize this. I don't know if you have or not. X root 2. It's 45/45/90 theorem. Hypotenuse has to be 5 root 2. You don't have to sit there and do Pythagorean theorem. That's slow. So each side length of my square or rhombus, whatever it is, it doesn't really matter, is 5 root 2. Plain and simple. The area is going to be 5 root 2 times 5 root 2, which is going to give you 25 times a 4, times a 2, which is 50. 50 is the answer. Another geometry problem. In triangle XYZ below, segment XZ is 7/8 of H. 7/8 of the height, which is the length of the altitude. What is the area of triangle XYZ in terms of H? So you guys all know that the area of a triangle is 1/2 base times height. And they said that this thing was 7/8 of H. That's what they said. So the area of this triangle has to be 1/2 the base, which is 7/8 the height, times the height. This is easy. 1 times 7 is 7. H times H is H squared. 2 times 8 is 16. That easy. On Friday, a computer was priced at $800. On the following Wednesday, the price was reduced 15%. On the following Friday, the price was further reduced by 20%. You know what most kids do is they add 15% and 20%, and that's what they discount it by. So it starts at 800. Wednesday, it is going to be 85% of that, because 100% minus 15% is 85%. So that is going to be $680. And then it says Friday we reduced it again. We reduced it by 20%. So it's going to be 80% of the 680. And I know there's other ways of doing this. They'll just take longer. It's $544. What percent of the original price was the final price? Interesting. So the final is 544 and the original is 800. It's an interesting way of doing it, but whatever. 544 over 800, 0.68, 68%. There you go. I do hope you do well on the ACT. I'm not being mean by assigning you ACT problems. I am legit trying to help you get into college. That is all I'm trying to do.